Been, but I don't wanna leave this place. There's no faith in Brooklyn. Yeah.
What is going on, guys? It is your boy Pete. Today we're going to be talking about action potentials or nerve impulses, but before we do that, I would just like to say that Wallace is stuck in Cambodia. So if you'd like to ask Wallace what's going on, maybe he'll tell you in the next podcast. I don't know. Before we establish what an action potential is, we need to understand that a neuron has what's known as a resting potential. And this resting potential is about negative 70 millivolts. And what's going on is that the concentration of potassium is kept very high inside the cell, and the concentration of sodium is kept very high outside of the cell. And so once we have that, we have what's known as a stimulus. So the dendrites receive a certain type of stimulus, and then this provokes the opening of sodium channels. And when we open sodium channels, the sodium that we kept on high concentrations outside of the cell rushes into the inside. And what this does is it increases the membrane potential of the cell. And again, we had started off with a negative 70 millivolt, and we're gradually working ourselves up. As we work ourselves up, if we hit a certain threshold level, or negative 55 millivolts, then we get what's known as a action potential. And so with an action potential and with the opening of sodium channels, even more sodium channels opening. And what we do is when more sodium channels open, more sodium rushes into the cell, and we increase the membrane potential. And this process in which we increase the membrane potential from when we had it at a resting state is known as depolarization, or making the membrane potential more positive. So this reaches a climax, or its peak phase, at about 30 millivolts. And so after we have that peak phase, we have repolarization, or bringing it back down to the resting potential. And so potassium channels now open. And potassium, again, like we said, was kept in high concentrations inside the cell. When we open our potassium channels, the potassium rushes out of the cell. And now while this is going on, a little after potassium channels open, sodium channels close. And the significance of this is that when we have our potassium channels opening and our potassium rushing out of the cell, that means that the cell is decreasing its membrane potential. After repolarization, we get what's called hyperpolarization. So as the potassium channels close, there's too much potassium that rushes out of the cell, and instead of the cell going back down to the resting potential of negative 70 millivolts, it goes to a membrane potential of about negative 80 millivolts, more negative than what we started off with. And so what we have is a refractory period. And during this period, sodium channels start to become activated again. While this period goes on, another stimuli cannot cause another action potential. And now, since we have potassium that had rushed out of the cell and sodium that came into the cell, we need to revert these two ions back to where they started. And so we use what's known as our sodium-potassium pumps, and they bring back high concentrations of sodium outside of the cell and high concentrations of potassium inside of the cell. And then our membrane potential goes back to negative 70 millivolts. And now we can sum this all up in a diagram. So we had our resting potential, and then we had some sort of stimulus that caused the opening of sodium channels. Sodium rushes in, it increases the membrane potential, and we have more sodium channels open, causing a further increase, and then we have our peak. This whole process is known as depolarization. Then we lower the membrane potential through the process of repolarization, opening potassium channels and closing sodium channels. And then we have what's called an undershoot, or again, our hyperpolarization phase that we just talked about. And during this phase, we are a little more negative than what we started off with. And then after the undershoot, we have what's known as our refractory period. And here we go back to our resting potential. So it's important to note that with action potentials, there exists an all or nothing principle. If a certain stimulus does not depolarize the cell enough to exceed the threshold, an action potential will not occur. And if it does, a full action potential will take place. Nothing in the middle. So that is all, guys. I hope you guys enjoyed this video. Please like, favorite, and subscribe if you enjoyed. Again, guys, the more you know, the better you are.